In the National Electrical Code, stables and tack houses are classified as agricultural buildings. All electrical equipment and wiring must be installed according to the requirements of Article 547. Electrical systems must be protected against physical damage and moisture. All wiring must be done by a qualified electrician. Specific requirements for stables and tack houses include lighting fixtures overhead in stalls. These must be protected by a metal cage or guard to prevent contact with the animals. Fixtures must be moisture resistant to withstand the humid environment. Receptacles must be weatherproof and made of a metal alloy or have a corrosion resistant finish. Receptacles should be mounted on weatherproof boxes. Ground fault circuit interrupter, or GFCI, protection is required for receptacles in damp or wet areas. Conductors must be properly insulated and protected against physical damage. Wiring methods allowed include non-metallic sheet cable, or NMB, or underground feeder cable, or OFF cable for dry locations, rigid metal conduit, or RMC for damp or wet locations, and polyvinyl chloride, or PVC conduit for dry locations only. Additional considerations include using shockproof lighting fixtures specifically designed for animal areas. Install ground fault circuit interrupters, or GFCIs, on all circuits supplying lighting or receptacles in stalls or tack houses. Use tamper-resistant receptacles to prevent accidental contact. Provide adequate ventilation to prevent the accumulation of moisture. Regularly inspect and maintain the electrical system to ensure safety. It is important to note that incorrect wiring can pose a significant hazard to both animals and humans in agricultural buildings. Always follow the NEC requirements and consult with a qualified electrician for any electrical work. Article 547(1) covers the scope of agricultural buildings. This article covers the application of wiring methods and equipment on agricultural buildings or parts of buildings that Article 547 covers. An agricultural building is defined as a structure that is not intended for human habitation and in which crops, livestock, or poultry are housed or produced, and may include storage areas for farm equipment and supplies. Article 547(3) addresses general wiring methods. In agricultural buildings that have insulated or equipment grounding conductors, the wiring methods must be identified and installed for the conditions considering the presence of corrosive aerosols, gases, and liquids. Article 547(4) covers the wiring methods allowed in agricultural buildings. Firstly, non-metallic cable, type NM, must be sheeted and installed as described in Article 334. Secondly, non-metallic underground feeder and branch circuit cable, type OFF, must be installed per Article 340. Thirdly, rigid metal conduit, or RMC, must be installed according to Article 344. Fourthly, intermediate metal conduit, or IMC, must be installed per Article 342. Fifthly, electrical metallic tubing, or IMT, must be installed per Article 358. Sixthly, liquid tight flexible metal conduit, or LFMC, must be installed according to Article 350. Seventhly, liquid tight flexible non-metallic conduit, or LFNC, must be installed per Article 356. Eighthly, armoured cable, or AC, must be installed as per Article 320. Ninthly, boxes and fittings must comply with Article 314. Article 547(5) covers equipotential planes. For interior equipotential planes, bonding requirements are provided to minimize voltage differences within specific areas where livestock are confined. For exterior equipotential planes, these serve to minimize step and touch potential in outdoor livestock areas. Article 547(8) discusses grounding. Grounding must comply with Article 250. Metal raceways, metal-clad cables, and metal enclosures must be bonded to the grounding electrode system. Article 547(9) discusses lighting fixtures. Lighting fixtures installed in agricultural buildings must be protected from physical damage and moisture. They should be suitable for wet or damp locations and be designed to minimize the entrance of dust, dirt, and moisture. Article 547(10) covers motors. Motors used in agricultural buildings must be totally enclosed or designed to minimize the entrance of dust, dirt, and moisture. They must also be protected from overload and overcurrent. Article 547(11) addresses other equipment. All other electrical equipment used in agricultural buildings must be suitable for the environment in which it is installed. It should be protected from physical damage, moisture, dust, and dirt. Article 547(12) covers outdoor locations. Electrical equipment installed in outdoor locations must be weatherproof and protected from physical damage. It must also be installed in accordance with the requirements of Article 225. Article 547(13) discusses separate buildings. Where two or more agricultural buildings are supplied by the same service, a disconnecting means must be provided at each building. The disconnecting means must be suitable for use as service equipment and must be readily accessible. Article 547(14) covers bonding. All metal parts of electrical equipment and wiring systems must be bonded together to form a continuous electrical path. This bonding helps to minimize the risk of electric shock. Article 547(15) discusses surge protection. In areas where lightning is common, surge protection should be provided to protect electrical equipment from damage caused by lightning strikes. Article 547(16) covers wiring for swimming pools. Wiring for swimming pools located in agricultural buildings must comply with the requirements of Article 680. Article 547(17) discusses emergency power systems. Emergency power systems should be provided in agricultural buildings where interruption of electrical service could result in serious injury or death to livestock or poultry. These systems must comply with the requirements of Article 700. Article 547(18) covers intrinsically safe equipment. Intrinsically safe equipment is permitted in agricultural buildings where flammable materials are present. This equipment must comply with the requirements of Article 504. Article 547(19) discusses electric fences. Electric fences must be installed in accordance with the requirements of Article 690. Firstly, the fence controller must be listed for the purpose. Secondly, the fence must be installed in a manner that minimizes the risk of electric shock to persons and animals. Thirdly, the fence must be grounded in accordance with Article 250. Article 547(20) covers solar photovoltaic systems. Solar photovoltaic, or PV, systems installed on agricultural buildings must comply with the requirements of Article 690. Article 547(21) discusses wind electric systems. Wind electric systems installed on agricultural buildings must comply with the requirements of Article 694. The NEC provides specific guidance on wiring and electrical safety in agricultural buildings to protect both animals and humans from electrical hazards. Some specific requirements may include firstly, grounding and bonding to minimize the risk of electric shock. Secondly, the use of ground fault circuit interrupters, or GFCIs, in wet or damp locations. Thirdly, proper wiring methods to withstand the corrosive environment often found in agricultural buildings. Fourthly, protection of electrical equipment from physical damage. Fifthly, regular inspection and maintenance of electrical systems. These requirements are designed to ensure that electrical systems in agricultural buildings are safe and reliable. Other considerations include, for example, the presence of dust, corrosive atmospheres, and the potential for physical damage. It's important to consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Always hire a qualified electrician to perform electrical work in agricultural buildings. Proper grounding and bonding is critical in agricultural buildings to minimize the risk of electric shock to both animals and humans. All metal parts of electrical equipment and wiring systems must be bonded together to form a continuous electrical path. This bonding helps to ensure that any fault current will quickly trip a circuit breaker or ground fault circuit interrupter, or GFCI, thereby reducing the risk of electric shock. Ground fault circuit interrupters, or GFCIs, are required in wet or damp locations in agricultural buildings to protect against electric shock. Ground fault circuit interrupters, or GFCIs, are designed to detect small amounts of current leakage and quickly shut off the power to the circuit, thereby preventing electric shock. Proper wiring methods are essential in agricultural buildings to withstand the corrosive environment often found in these locations. Wiring methods such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and liquid tight flexible metal conduit, or LFMC, are often used in agricultural buildings because they are resistant to corrosion. Protection of electrical equipment from physical damage is also important in agricultural buildings. Electrical equipment should be installed in locations where it is not likely to be damaged by livestock, equipment, or other object. Regular inspection and maintenance of electrical systems is essential to ensure that they are safe and reliable. The electrical system should be inspected regularly for signs of damage, wear, or corrosion. Any problems should be corrected promptly to prevent electrical hazards. Article 547 requires that all equipment be suitable for the environment. This means that the equipment must be designed to withstand the conditions present in the agricultural building, such as dust, moisture, and corrosive substances. Article 547 also requires that all wiring be installed in a neat and workmanlike manner. This means that the wiring must be properly supported and secured, and that it must be free from sharp bends or kinks. Article 547 also requires that all electrical equipment be properly grounded. Grounding is essential for protecting people and animals from electric shock. The grounding system must be properly installed and maintained to ensure that it is effective. Article 547 also requires that ground fault circuit interrupters, or GFCIs, be installed in certain locations in agricultural buildings. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by quickly shutting off the power to a circuit if a ground fault is detected. Ground fault circuit interrupters, or GFCIs, are required in locations where there is a high risk of electric shock, such as wet or damp areas. Article 547 also requires that surge protection be provided for electrical equipment in agricultural buildings. Surge protection is designed to protect equipment from damage caused by voltage surges, such as those caused by lightning strikes. Surge protection is especially important in agricultural buildings because they are often located in areas where lightning is common. Article 547 also requires that emergency power systems be provided in agricultural buildings where interruption of electrical service could result in serious injury or death to livestock or poultry. Emergency power systems are designed to provide power to essential equipment such as lighting, ventilation, and heating in the event of a power outage. Article 547 also requires that electric fences be installed in accordance with the requirements of Article 690. Article 690 provides specific requirements for the installation of electric fences, including requirements for the fence controller, the fence wiring, and the grounding system. Article 547 also requires that solar photovoltaic, or PV, systems installed on agricultural buildings comply with the requirements of Article 690. Article 690 provides specific requirements for the installation of solar photovoltaic, or PV, systems, including requirements for the panels, the wiring, and the inverters. Article 547 also requires that wind electric systems installed on agricultural buildings comply with the requirements of Article 694. Article 694 provides specific requirements for the installation of wind electric systems, including requirements for the turbine, the wiring, and the inverters. Article 547 is an important article in the National Electrical Code, or NEC, that provides specific requirements for the installation of electrical equipment and wiring in agricultural buildings. By following the requirements of Article 547, you can help to ensure that electrical systems in agricultural buildings are safe and reliable. Article 547.5 covers equipotential planes. Equipotential planes are intended to minimize voltage differences within an area. An interior equipotential plane, as described in 547.5a, is required in livestock confinement areas that contain metallic equipment that is accessible to animals and likely to become energized. The equipotential plane must be bonded to the grounding system. This bonding helps to minimize voltage differences between the metallic equipment and the surrounding floor or earth, reducing the risk of electric shock to animals. The equipotential plane can be constructed using various methods, such as copper mesh, reinforcing steel, or other conductive materials embedded in the concrete floor. The plane must cover the entire area where livestock are confined and have access to metallic equipment. Exterior equipotential planes, as described in 547.5b, are used to minimize step and touch potential in outdoor livestock areas. Step potential is the voltage difference between 2 points on the ground that a person or animal could step on. Touch potential is the voltage difference between a metallic object and the ground that a person or animal could touch. Exterior equipotential planes are typically constructed using buried ground rings or grids that are bonded to the grounding system. The ground ring or grid must be installed around the perimeter of the livestock area and extend outward to a distance sufficient to minimize step and touch potential. The specific requirements for equipotential planes can vary depending on the type of livestock, the size of the confinement area, and the soil conditions. It's important to consult with a qualified electrician and refer to the NEC for specific requirements in your area. Proper installation and maintenance of equipotential planes are essential for protecting livestock from electric shock. In livestock confinement areas, metallic equipment such as feeders, waterers, and stalls can become energized due to faults in the electrical system. If an animal comes into contact with energized equipment and the surrounding floor or earth, it can receive an electric shock. Equipotential planes help to minimize voltage differences in these areas, reducing the risk of electric shock. Firstly, they provide a low impedance path for fault current to flow back to the source. Secondly, they help to equalize the voltage potential between metallic equipment and the surrounding floor or earth. Thirdly, they reduce step and touch potential in outdoor areas. In addition to equipotential planes, other safety measures should be implemented in agricultural buildings to protect livestock from electric shock. Firstly, use ground fault circuit interrupters or GFCIs in wet or damp locations. Secondly, ensure that all electrical equipment is properly grounded and bonded. Thirdly, regularly inspect electrical systems for signs of damage or wear. Fourthly, provide adequate ventilation to prevent the accumulation of moisture. Fifthly, use insulated mats or flooring in areas where livestock are likely to come into contact with electrical equipment. By implementing these safety measures, you can help to create a safer environment for livestock in agricultural buildings. The National Electrical Code, or NEC, Article 547 is dedicated to addressing the specific electrical requirements for agricultural buildings. This article recognizes the unique challenges and hazards associated with these environments, such as the presence of dust, moisture, corrosive substances, and large animals. Understanding and adhering to the provisions outlined in Article 547 is crucial for ensuring the safety of both animals and humans in agricultural settings. Firstly, scope and definitions. Article 547.1 defines agricultural buildings as structures not intended for human habitation where crops, livestock, or poultry are housed or produced. This includes barns, stables, poultry houses, and similar structures. Secondly, general wiring methods. Article 547.3 emphasizes that wiring methods must be suitable for the specific conditions present in agricultural buildings. This includes protection against physical damage, moisture, and corrosive substances. Thirdly, grounding and bonding. Article 547.4 requires that all metal parts of electrical equipment and wiring systems be properly grounded and bonded to minimize the risk of electric shock. Fourthly, equipotential planes. Article 547.5 introduces the concept of equipotential planes, which are intended to minimize voltage differences in livestock confinement areas. Fifthly, wiring methods. Article 547.6 specifies the types of wiring methods that are permitted in agricultural buildings, such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and non-metallic conduit. Sixthly, lighting fixtures. Article 547.7 requires that lighting fixtures be protected from physical damage and moisture, and that they be suitable for wet or damp locations. Seventhly, motors. Article 547.8 requires that motors be totally enclosed or designed to minimize the entrance of dust, dirt, and moisture. Eighthly, other equipment. Article 547.9 requires that all other electrical equipment be suitable for the environment in which it is installed. Ninthly, outdoor locations. Article 547.10 covers the requirements for electrical equipment installed in outdoor locations. Tenthly, separate buildings. Article 547.11 addresses the requirements for separate buildings that are supplied by the same service. 11thly, surge protection. Article 547.12 recommends the use of surge protection to protect electrical equipment from damage caused by lightning strikes. 12thly, emergency power systems. Article 547.13 requires that emergency power systems be provided in agricultural buildings where interruption of electrical service could result in serious injury or death to livestock or poultry. Article 547 of the NEC is an essential resource for electrical contractors, engineers, and inspectors who work on agricultural buildings. By following the provisions outlined in this article, you can help to ensure the safety and reliability of electrical systems in these challenging environments. Proper electrical safety in stables and tack houses is crucial to protect both the animals and the people who work in these environments. Horses and other livestock are particularly vulnerable to electric shock, and faulty wiring can create a dangerous situation. There are several key areas to focus on when ensuring electrical safety in stables and tack houses. Firstly, wiring methods. Use appropriate wiring methods for the environment. Rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and liquid-tight flexible metal conduit, or LFMC, are good choices for areas where there is moisture, dust, or the potential for physical damage. Secondly, grounding and bonding. Ensure that all metal parts of the electrical system are properly grounded and bonded. This includes the metal conduit, electrical boxes, and equipment enclosures. Proper grounding and bonding helps to minimize the risk of electric shock. Thirdly, ground fault circuit interrupters, or GFCIs. Install ground fault circuit interrupters, or GFCIs, in all wet or damp locations, such as wash stalls and areas where water is used for cleaning. Ground fault circuit interrupters, or GFCIs, will quickly shut off the power if a ground fault is detected, preventing electric shock. Fourthly, lighting. Use vapor-tight or dust-tight lighting fixtures in areas where there is moisture or dust. Protect lighting fixtures from physical damage by using guards or cages. Fifthly, receptacles. Use weatherproof receptacles in outdoor locations and in areas where there is moisture. Cover the receptacles with weatherproof covers when they are not in use. Sixthly, electrical panels. Locate electrical panels in dry, accessible locations. Protect the panels from physical damage. Seventhly, surge protection. Install surge protection devices to protect electrical equipment from voltage surges caused by lightning or other sources. Eighthly, regular inspections. Inspect the electrical system regularly for signs of damage or wear. Replace any damaged or worn components immediately. Ninthly, qualified electrician. Have all electrical work performed by a qualified electrician who is familiar with the NEC requirements for agricultural buildings. By following these guidelines, you can help to ensure electrical safety in stables and tack houses and protect both the animals and the people who work in these environments. The NEC provides specific requirements for the installation of electrical equipment and wiring in agricultural buildings. These requirements are designed to protect both animals and humans from electrical hazards. It is important to follow these requirements carefully when installing electrical systems in stables, tack houses, and other agricultural buildings. Remember, always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. And always hire a qualified electrician to perform electrical work in agricultural buildings. In agricultural buildings, it is essential to use appropriate wiring methods that can withstand the harsh environmental conditions. The NEC specifies several wiring methods that are suitable for use in agricultural buildings. Firstly, rigid metal conduit, or RMC. Rigid metal conduit, or RMC, is a heavy-duty conduit that provides excellent protection against physical damage and corrosion. It is suitable for use in both wet and dry locations. Secondly, intermediate metal conduit, or IMC. Intermediate metal conduit, or IMC, is a lighter weight conduit that provides good protection against physical damage and corrosion. It is suitable for use in both wet and dry locations. Thirdly, electrical metallic tubing, or IMT. Electrical metallic tubing, or IMT, is a lightweight conduit that is suitable for use in dry locations. It is not suitable for use in wet locations or in areas where it is subject to physical damage. Fourthly, non-metallic conduit. Non-metallic conduit, such as polyvinyl chloride, or PVC, is a lightweight conduit that is resistant to corrosion. It is suitable for use in both wet and dry locations, but it is not as strong as metal conduit. Fifthly, cable. Cable such as non-metallic sheath cable, or NM cable, and underground feeder, or ARF cable, is a flexible wiring method that is suitable for use in dry locations. It is not suitable for use in wet locations or in areas where it is subject to physical damage. When selecting a wiring method for an agricultural building, it is important to consider the specific environmental conditions and the potential for physical damage. In areas where there is moisture, dust, or corrosive substances, it is best to use rigid metal conduit, or RMC, intermediate metal conduit, or IMC, or non-metallic conduit. In areas where there is a risk of physical damage, it is best to use rigid metal conduit, or RMC, or intermediate metal conduit, or IMC. It is also important to follow the NEC requirements for the installation of wiring methods in agricultural buildings. These requirements include proper support, grounding, and bonding. By following these requirements, you can help to ensure that the electrical system in an agricultural building is safe and reliable. Equipotential bonding is a crucial safety measure in agricultural buildings, particularly in livestock areas. It involves connecting all metallic objects that livestock can come into contact with to a common grounding point, creating an equipotential zone. This minimizes voltage differences between these objects, reducing the risk of electric shock to animals. The NEC provides specific guidelines for equipotential bonding in agricultural buildings outlined in Article 547. The key components of an equipotential bonding system in an agricultural building include firstly, bonding conductor, a copper wire or busbar that connects all metallic objects to the grounding electrode system. Secondly, grounding electrode system, a system of electrodes, such as ground rods or plates, that are buried in the earth and connected to the building's electrical system. Thirdly, metallic objects. Any metallic objects that livestock can come into contact with, such as waterers, feeders, fences, and stalls. The steps involved in installing an equipotential bonding system in an agricultural building include firstly, identify metallic objects. Identify all metallic objects that livestock can come into contact with in the area to be bonded. Secondly, connect bonding conductor. Connect a bonding conductor to each metallic object using appropriate connectors and techniques. Thirdly, connect the grounding electrode system. Connect the bonding conductor to the grounding electrode system, ensuring a solid and reliable connection. Fourthly, test the system. Test the equipotential bonding system to ensure that it is functioning properly and that there are no voltage differences between metallic objects. Regularly inspect and maintain the equipotential bonding system to ensure that it remains effective. Look for signs of corrosion, damage, or loose connections and repair or replace any damaged components promptly. Equipotential bonding is an essential safety measure that can help to protect livestock from electric shock in agricultural buildings. By following the NEC guidelines and implementing a properly installed and maintained equipotential bonding system, you can create a safer environment for animals and reduce the risk of electrical hazards. The proper selection and installation of electrical boxes and fittings are crucial for ensuring electrical safety and compliance with the NEC in agricultural buildings. The NEC provides specific requirements for electrical boxes and fittings in Article 314. Firstly, material. Electrical boxes and fittings must be made of materials that are suitable for the environment in which they are installed. In agricultural buildings, this typically means using corrosion-resistant materials such as galvanized steel, stainless steel, or non-metallic materials. Secondly, size. Electrical boxes must be sized appropriately for the number and size of conductors that they will contain. The NEC provides specific guidelines for box fill calculations in Article 314.16. Thirdly, type. The type of electrical box must be suitable for the application. For example, weatherproof boxes must be used in wet or damp locations, and explosion-proof boxes must be used in hazardous locations. Fourthly, installation. Electrical boxes and fittings must be installed in accordance with the NEC requirements. This includes proper support, grounding, and bonding. Fifthly, markings. Electrical boxes and fittings must be marked with the manufacturer's name, voltage rating, and other relevant information. When selecting electrical boxes and fittings for agricultural buildings, it is important to consider the specific environmental conditions and the potential for physical damage. In areas where there is moisture, dust, or corrosive substances, it is best to use corrosion-resistant materials. In areas where there is a risk of physical damage, it is best to use boxes and fittings that are made of heavy-duty materials. It is also important to follow the NEC requirements for the installation of electrical boxes and fittings. These requirements include proper support, grounding, and bonding. By following these requirements, you can help to ensure that the electrical system in an agricultural building is safe and reliable. The NEC requires that all electrical boxes and fittings be properly grounded and bonded. Grounding is the process of connecting the metal parts of an electrical system to the earth. Bonding is the process of connecting the metal parts of an electrical system together to form a continuous electrical path. Grounding and bonding help to minimize the risk of electric shock by providing a lower impedance path for fault current to flow back to the source. The NEC also requires that ground fault circuit interrupters, or GFCIs, be installed in certain locations in agricultural buildings. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by quickly shutting off the power to a circuit if a ground fault is detected.